Hey guys, welcome to 5.2, Verifying Trig Identities. If you'd like, try a little warm-up, pause the video, try these warm-up problems, and then play it to show off, to see how it's done. All right, so for the first one, simplifying this, obviously I want to try to make this into one fraction, so I'm going to make a common denominator. So I'll do that. Cosecant minus 1 on this side. I like to change this to a plus -1, just makes it a little bit easier, I think, or a little less likely to forget to change a sign. So I multiplied each side by the other one's denominator, so I'll make a common denominator. Starting to simplify now. 1 distributed into this on the top of the numerator just makes it cosecant minus 1. Then distributing the -1 in here, I've got a minus cosecant and a minus 1. And that is all going to be over. If I FOIL this out, if I multiply these two things together, I'm going to get cosecant squared minus 1. Continuing to simplify this, I've got a cosecant and a minus cosecant, so just combining like terms on top, that cancels those out. Then -1 minus 1 makes a -2. The denominator, cosecant squared minus 1 is equal to cotangent. If we take the 1 plus cotangent squared equals cosecant squared, and I subtract a 1 from both sides, I get that cotangent is equal to cosecant squared minus 1. So I can change that to cotangent squared. We're getting closer. We've combined it into one fraction, and now we've got one term over one term. So the last thing would be, can I make this not be a fraction anymore? Cotangent is the reciprocal of tangent, so I can take tangent and flip it up to the top, and now this will no longer be a fraction. So this can be -2 times tangent squared. Taking a look at this one, cotangent and tangent are reciprocals of one another, so right away I could make this into cotangent squared times 1 over cotangent squared plus cotangent squared. Cotangents cancel each other out, and now this is 1 plus cotangent squared. 1 plus cotangent squared, that was our Pythagorean identity we used over here. 1 plus cotangent squared is equal to cosecant squared. So that is as simple as that one gets. All right, so 5.2. Verifying trig identities. This is, in some ways, a little bit simpler than what we did in the previous video and in the warm-up, because we're going to know what the answer should look like. We're now verifying the steps to show why the two things are equal to one another. All right, now before we get started, I want my clicker to work. There we go. So we're going to be proving that both sides of a trig equation are equal. I want to talk a little bit about the Pythagorean identities. We have sine squared plus cosine squared equals 1. We've got tangent squared plus 1 equals secant squared. And we have 1 plus cotangent squared equals cosecant squared. One thing that I want to point out, these only work when sine, cosine, when all of the stuff is squared. Sine plus cosine does not equal 1. Sine squared plus cosine squared equals 1. Tangent plus 1 does not equal secant. Tangent squared plus 1 equals secant, and secant squared, and so on. The second thing is a pneumatic device that we often use and that I'm going to reference in future videos to help students remember these is Santa Claus, Taylor Swift, Captain Crunch. So if you can remember that acronym, you really don't need to write any of these down. It's SC, Taylor Swift, and Captain Crunch. And then you just have to remember how to fill things in. So sine and cosine go together, tangent, cotangent, and then that leaves secant and cosecant. So just a little thing that you can use to try to remember this. All right, so our strategies when we're verifying. First off, if you have fractions, chances are you're going to combine them. Sometimes you'll split one fraction into two, but it's much more likely that you're going to combine two fractions into one. Multiplying a fraction by its conjugate. If we go back to that warm-up problem, these two are conjugates, right? Cosecant plus 1, cosecant minus 1. If you've got go from a plus to a minus, that makes it a conjugate. When you multiply those together, chances are you're going to get a Pythagorean identity, like we did for that warm-up problem. Let's see. Factoring, we did a little of that in 5.1. That's going to be a pretty common one. Using the identities, that's going to be pretty much every single one. Reciprocal, quotient, Pythagorean identities. Working both sides separately until they match. I'm going to talk more about this in the first example. And converting everything to sine and cosine. This is sort of a fail-safe. It's something we lean on. It doesn't work every time, but if you've got no other idea what to do, converting to sine and cosine can be a good strategy. Okay, so first up, verifying this. Now, when we talk about working both sides of the equation, what we mean is I can't do something like this, where I subtract secant 4x from both sides, right? I can work on this side on its own, I can work on this side on its own, but I can't bring stuff from this side over to this side and vice versa. All right, and this is one where I'm really only going to work on the one side anyway. So looking at this, another little hint for these. Of the two sides, it's generally easier to take the more complicated side and make it the equivalent of the simpler side than vice versa. It's going to be easier for me to break this down into something smaller that will eventually become this than to try to expand this one. Okay, so looking at this. I've got stuff that's squared, I've got ones next to it, I'm immediately thinking Pythagorean identities. Our Taylor-Swift identity says that tangent squared plus 1 is equal to secant squared. So the numerator, I can just change to secant squared. Well, that's good because I'm trying to make it secant to the fourth, so I'm sort of halfway there. All right, the denominator, 1 minus sine squared. If I look at the Santa Claus one, sine squared plus cosine squared equals 1. Well, if I subtract sine squared from both sides, I get cosine squared equals 1 minus sine squared. So 1 minus sine squared is equal to cosine squared. Super common one going forward. So this denominator can be changed to cosine squared. So now I'm trying to get this side to equal secant to the fourth. I have secant here, I have cosine. Is there a property that relates cosine and secant? The answer is yes. Cosine is equal to 1 over secant. And so if I change this, secant squared over 1 over secant squared, now I can do keep change flip here, and it's secant squared times secant squared over 1. So it's really secant squared times secant squared, which is secant to the fourth. Now I've shown step by step why these two things are equal. I got this side to match this side, so boom, I'm done. All right, next one. This one looks a little more complicated. That's all right. This side is definitely bigger than this side, so I'm going to focus on this one. One thing that I could do to start this, because I have sine and cosine over here, this side is cotangent, I can maybe change this to be negative 2 times cotangent is equal to cosine over sine, so negative 2 cosine over sine, and then try to make this look like this instead. That might save me a step. It might give me a little more insight of like where I should go, what my next step should be. Okay. Looking at the other side now. Two fractions, conjugates for denominators. I'm obviously going to start out by multiplying. I'm going to make one fraction by multiplying each side by the other's denominator. And I'm going to change this to a plus negative sine x again. Not 100% necessary, but I'm just doing this as many times as I have, teaching this as often as I have. That's a good way to go to avoid mistakes. Okay, simplifying the numerator. We distribute the sine x in there, and it is going to be sine minus sine cosine. Distribute the negative sign into here, and it is minus sine cosine. If you FOIL out the bottom, again, it's a difference of squares, so it's going to be 1 minus cosine squared. There's a Pythagorean identity. Okay, simplifying the top. Combining like terms. Sine minus sine cancel out, and I've got 2 of the negative sine cosine, so that's going to be negative 2 sine cosine. Look at that, it's getting closer because it's negative 2 cosine. I just need to get rid of that sine in the numerator. 1 minus cosine squared. If we look at the Santa Claus one and monkey around with it a little bit, we can show that 1 minus cosine squared is equal to sine squared. Well, that sine cancels 1 from the bottom, and so we're left with negative 2 cosine over sine. Now both sides match, so we're all good. All right, so there is the homework assignment. 8 problems. There is a series of videos that I made going through all 8 of these problems. So I would encourage you to try them on your own, see how far you can get. Try different things. These are problems where you might try one strategy and you run into a dead end and you just have to like erase everything and start over and try something different. Really try to do them on your own, but if you need further explanation more than like what just the answer key itself could provide, I have a video going through each one of these problems for you guys to use.